algorithms that deal with arrays. So go ahead and crank open a new file with your usual boilerplate. Include IOStream, include string. We probably won't use strings, but it's nice to have. I'm sure we won't use fstream, so I'm going to take that one out. I lost my system pause, so I'm going to put that back in there. Okay, so what are we going to do? Let's put some comments here. We're going to write code that uses a for loop to add the numbers 1 to 10. Then we're going to write code that adds the numbers in an array. Then we're going to write code that finds a specific value in the array setting a variable found at to the index value, or setting found at, this is a long one, sorry, to -1 if not found. Alright, the first one's real easy. Write a code that uses a loop, a for loop, to add the numbers from 1 to 10. So for int x is equal to 1, x is less than or equal to 10, x plus plus. But we need to add the numbers, so we need to declare a total up above. Something like that. That handles this first one. I'm going to eventually cut these comments and move them on top of the code bits. I may as well run it and make sure. I should print the answer out to make sure. So cout summation 1 to 10 equals, followed by that total, followed by the NDO. Just to make sure it works. It ought to be 55, just from experience. Here we go, 55. Just like we did here, to write code that adds all the numbers in an array, we're still going to need a counter, but we're not going to add the value of that counter to our total. Instead, we're going to add the array element at that position. So I usually give that counter a different name. I call it I for index rather than X. You can call it anything you want to. You can call it Wilma or thank goodness the election is over or something like that. But anyways, total is already defined, but so I guess I'm not going to redeclare it, but I am going to reinitialize it to 0. Otherwise it would just increase. Now we don't have an array to play with yet, so let's declare an array. Let's declare an array of ints. I'm going to just call it IA. And I'm going to put some numbers in it. A 10, a 20, a 33, a 41, a 50, and a 100. Now we're going to need to know how many elements we have here. And we really don't know that, do we? So I almost wish I hadn't declared it that way. I think we're going to have to resort to using the size of function in order to determine the max element, or the length of the array. In Java or Python, it's really easy to get the length of the array. But in this language, I'm going to declare a variable called length, and I'm going to set it equal to the size of the array divided by the size of an int. That will tell me how many items are available in that array. I would not have had to have done that if I had defined a constant up above that indicated how many elements were in the array, but in this case I wasn't really sure. I was just making it up as I went along. It turned out to be 6. So somehow you have to get the size. Whether the size is defined as a constant, because that's how you declare the array, or whatever. This is, by the way, not my favorite way of getting the length of an array. I don't like getting the length of the array, but when you have an array of indeterminate length like that, that's the way that I know. So now we need a for loop, but arrays don't start at 1. They start at 0. So int I is equal to 0. I is less than, but not up to and not including the length. I plus plus. And the total is plus equal to the array of indices at position I. Now let's just print out . Okay, run it, make sure it works. I assume that's right, 254. I didn't choose numbers that were deliberately easy to add. I should have just made it, 10, 20, 30, 40, 50, 60. That would have been easy. I assume that's right. All right, is anybody getting syntax errors I need to help with? I see people holding their heads like y'all are in pain. I hope I'm not the source of it. Okay, now we're going to write code that will search this array for a specific value. We want to find out, for example, where 50 is in this array. We want to know what position it's at. Well, we can eyeball it. That's position 0, 1, 2, 3, so it's at position 4. But we want to write some code that'll do that. Let's do that. I'm going to make up a different array name, though, I guess. I don't know. Now I'm going to leave it the same. But when I post this code, I'll tell you what we're going to do. Do this. Before this code, this int total is equal to 0 and the summation 1 to 10, all that, put an open brace there and put a close brace here. That's going to break some code underneath us. It's going to break this one. We're going to have to add an int there. Now do that again. Put an open brace before that int total is equal to 0 and a close brace after the cout on both sets of code. This time it didn't format it magically for me. Okay, the reason I'm doing this is so that each piece of this code would compile even without the piece above it. All right, let's do this one more time. We're going to make one more array. Why not just copy these 3 lines, though? We still need an array. We don't need a total, though. We're not looking for a total. But we do need an array, and we do need a length of the array. So there we go. We're going to need a for loop again that will search the array. But we're going to need a found at. I'm going to go ahead and paste this comment down here. I'm going to cut that comment. It's the third set of comments. I'm going to come down here and paste it above this code. Write code that will find a specific value in the array, setting a variable found at to the index value of that element, or setting found at to -1. So that means that we have to have that variable found at before we do anything else. Int found at, and then we're going to set it equal to -1 because we haven't found anything yet. So we need a for loop. For int I, and again I'm using I because when I'm processing arrays, I care about the index, and so I'm just using I for index. I is equal to 0, I is less than the length of the array, I plus plus. So we also need to know what value we're looking for. So we need to declare a variable that'll hold the value that we're looking for. I'm going to call it target. Int target. Which one of these values do we want to look for? Let's say that 41 is our favorite number. So we're looking for 41. So our code is going to be if that element at position I is equal to our target, we have found it. So we set found at equal to 1. I put X there. I meant to put I. I said I. And then we're going to print out underneath here. Now there's a problem with this code, but we'll fix it in a minute. Let's do this. Cout target found at ENDL. It said 41 was found at position 1. Is that true? Oh, why did I put that equal to 1? That's supposed to be an I there. My mistake. Fix this line if you typed a 1 like I did. So it found 41 at index value 3. Is that correct? Yeah, because that's 0, that's 1, that's 2. So it found the 41 at 3.
If you had 41 in there multiple times, would it mark each one?
It wouldn't mark each one. It's only going to mark the last one. That's an excellent question because that's what's broken about this code. Change another one of these to 41 as well. Like let's just put 41 right as the second one. Excellent question. Because when we run it, it still says it found it at 3. And we're going, hey, but it's also right there at position 1. And so our problem is we're not breaking out of the code at that point.
Okay.
There's 2 fixes. One which I would probably prefer to do, but then there's another one which is more computer science correct. Here's what I would do. I'm in love with a break statement, so after I found it, what I would do is break right there. That's my favorite fix. but you can also modify your for loop. Keep doing this while found at is equal to -1. So what I did is I added an AND clause to my for loop. And as soon as it finds something, as soon as found at becomes something different than -1, it'll exit the loop. So now when it runs, it's going to find the first one and bail out. So it found it at 1 that time. This is a correct implementation. We're going to call this the summation array, not summation, that was a previous one, search algorithm. We're going to call the one above that the array summation algorithm. And then lastly, this top one is just a summation algorithm. Not summing an array. We just kind of did that one for reference. It should look really familiar. So that's a summation algorithm. Now, since your prof is a jerk, he's going to make you memorize these things for the final exam. However, your prof isn't too big of a jerk because it's open notes, so it wouldn't be that hard to do. And if you're going to skip the final, then, you know. And we mentioned that, right? My goal is, or not my goal, but if you're happy enough with your 2 scores average, you can just use that, the average of your previous 2 exams as your final. But if you want to raise one of them, or I mean if you want to raise your average, you could go ahead and take the final and try to beat that. If you take the final, try to beat it, but fail to beat it, I'm not going to count you off. I'm not going to lower your score just because you made a valiant attempt at raising your grades. So if you made C's on your last 2 exams and you think that you can make a B on the final, go for it. No reason not to. Okay, so anyways, we have done 3 arrays. I think that's, 3 algorithms. This old one, this first one was kind of old hat. We should have had it burned into our brain already, even though I did not necessarily call it by that name. This one we did not call it by that name. Something wrong here with my formatting. There we go. So why did we do this? Well, for one thing, it's practice about dealing with arrays. Now there's one more syntax for arrays, which C++ stole from Java, who stole it from C#. So it's a great syntax. And it's called the for each syntax. I'm going to need to Google it to make absolutely sure. So C++ for each syntax. The C++ for each syntax. I love that new syntax. No. Alrighty. That's a little bit overly enthusiastic. But it's also called a range-based loop. Apparently that's one of its official names. In C# it's called for each. In Java they started calling it for each even after they gave it a different name to begin with. Here they're calling it range-based loop. I don't recall which our PowerPoint calls it, but the syntax for it's pretty cool. Go ahead and copy this array one more time. So let's tack on one more pair of curly braces, one more array declaration. And again, why am I making you do that each time? Just because I want each block of code to be complete unto itself so that you can copy and paste it into another program. Now let's declare a total, set it equal to 0. Now for every x in the array, this will look familiar to the Python users, total plus equals x. Then print out our total. Array summation equals plus total plus inline. Except you don't use pluses in this language, you use arrow, arrow. compare that to this one. I'm going to copy, you don't have to. But here was our first array summation algorithm. I'm going to paste that underneath this one. Shrink it a little. There we go. Which one's easier? If you had to memorize one of them, would you rather memorize these 5 lines or pretend that total was declared under there? Anyways, the correct answer, I will give you your opinion, is that this is much groovier because this just gives you a variable that toggles through all the values as it traverses the array, copying them into X. So you don't have to do any array references at all. You don't have to do any subscripts in order to get this one to work. So this is kind of like a magic for loop. It's called range-based or for each. We'll look to see what the PowerPoint calls it. And it's a nice syntax for dealing with arrays. And you'll see this syntax repeated as you learn to go and use other structures like vectors and array lists and all stacks and all sorts of things that C++ supports, abstract data types. So this is a really nice way of doing it. And when you go to take Java as well, you'll see this repeated a lot in Java, and it's also the Python way of doing it. It's a more sophisticated syntax. It makes it easier than having to do it this way. So that's why C++ adopted it as well. Let's go to the PowerPoint. Okay, they did call it a range-based as well. So the range-based for loop is a loop that iterates once for each element of an array. Each time the loop iterates, it copies an element from the array to a built-in temporary variable known as the range variable. You don't have to know the length of the array. You don't have to have a counter variable. You do not have to worry about stepping outside the bounds of the array. All of that is handled for you. So the syntax is like this. For, same word, but instead of saying int x equals 0, x is less than the length of the array, x plus plus, it looks like this. For data type, whatever data is stored in the array. We've been using arrays of ints. So int, and then range variable. X made a good one. And then colon, the name of the array. And then you have some statement or statements that follow. Let's demonstrate the difference between them again. We will print out an array of colors using both syntaxes. So string colors, square braces, is equal to red, green, blue, orange. Now we're going to need the same things that we did the first time we did an array summation. We don't need a total because we're not printing anything. We're not printing a total. We're just printing each item in it. But we will need a length. So int length is equal to the size of the colors array divided by the size of a string. That's how we will calculate the length of our array. And we will need a counter. So for int I is equal to 0, I is less than length, I plus plus, let's see out that element. See out colors at that specific value, ENDL. copy that colors array, and we're going to write a for loop that steps through it using the range-based for. For every string that you find in the colors array, print out that string. Okay, so again I'd ask you which one looks niftier, which one looks easier to remember and use. If you're burned in already on using array-based indexing into arrays, then this way may actually look better to you. So all the C++ programmers who started programming C++ in 1990 were just as happy doing it this way. But we do have this new toy. We can do it this way as well. The advantages to the range-based array are that 1, you don't have to have a counter. 2, you don't need to know the length of the array. And since you don't need to know the length of the array, 3, there's no possibility of accidentally going past the end of the array. That's really important for something like this because this syntax here for calculating the length of the array is not 100% guaranteed to work in some circumstances. I don't think we're going to run into any of those circumstances. But there we go. So this is a for loop to print an array. This is a, I'm going to call it for each, range-based loop to print an array. All right. I think we're good. I think we've covered enough for today. I think we will move on from arrays to something else, but we will give some homework. What is our homework going to be? Write a program that lets the user enter 10 scores. I'll fix the typos. Storing those scores into an array of doubles. Then write a for loop that will print the scores out. Also, write a for loop that will calculate the total and the average of those scores. So you're not saving to file or reading from file or anything, weird like that. We're just going to ask the user for the scores. So you're going to declare your array beforehand. Just as a reminder, how do you do that? Well, they're doubles, aren't they? Double scores like that, and you specify the length. And if you want to initialize them all to 0, you could do that. So that would be how I would create my variable. Then I would have some kind of loop that would read into it. Now we have this, write a for loop that will print the scores out, then write a for loop that will calculate the total and the average of those scores, but use a for each range-based loop for one of those, and an ordinary for loop for the other. All right, does that make sense? We can talk more about it on Thursday, maybe do an in-class assignment that's kind of similar, but really I think y'all know how to do this at this point. We will do an in-class assignment that covers something like that. So we'll make this due Monday night. And why don't we call it a day? Let's make a Dropbox for what we did today. And those of us who like to stare at election results can go home and do that. Those of us who went to sleep can do that.
Is it, or M? Is M today or no?
I haven't added a new drop. It will be in. We will call this one array loops. Okay, There it is, array loops. Go ahead and put it there. And this will be homework, assignment number 10.